All right, I don't think I'm going to do this entire example, but I'll do a quick part of it. This question here asks you to plot a slope field at each designated point for the differential equation dy dx equals 2x over y. Again, the concept here is pretty straightforward. Basically, when you're plotting a slope field, the slope field is showing you a representation of a slope at each particular point on the graph. And again, they've given you a dy dx, so they're giving you an equation telling you about slopes if you have different x and y values. So just pick the x and y coordinate, you put it in, and you can plot a little line with that slope. So for example, this is the point 1, 1. So if I'm going to plot the point 1, 1, I can put 2 times 1 in to the numerator, and the y value is 1, and that equals 2. And it just tells me the slope's supposed to be 2. That's a little bit more rise than run, so maybe that looks something kind of like that. I've got the point 1, 2. It's 2 times the x, which is 1, and then over the y value, and that just equals 1. So I show a slope of about 1 right there. You want to watch your positive and negative signs. For example, if I do 1 at -1, comma 1, I get 2 times the x value, which is 2 times -1, over the y value, which is just positive 1. And that's going to be a slope of -2. So the slope of -2 will be kind of steep. It'll be going like that. For these values here, the x value is going to be 0, and so you're going to end up with horizontal lines there and there and there. Be careful, if your y value is 0, you'd be dividing by 0, that would be undefined, that would be a vertical line. So you can kind of see the type of thing that you're going to end up doing here. I think these slopes are just going to be the opposite direction of those slopes because you just have the sign of your x changing. But that's the basic concept for drawing a slope field. I'm going to take a look at an example of a situation where you're going to take a word problem, set up a differential equation based off the word problem, and then solve that using the information that you're given. So this problem asks you to write a differential equation expressing the statement. The statement says the rate of change over time of the weight of a baby bird is directly proportional to its current rate, okay? Or to its current weight. The key here is rate of change over time of the weight. Okay, a rate or a rate of change is a derivative. So we're looking at the rate of change of the weight over time. If you're told that something varies directly, if you're told that it's directly proportional, that sort of thing, what you're really being told, this goes back to Algebra 1, and what you're really being told is that a constant is being multiplied by your input to give you your output, okay? Very simple relationship, something you should have learned about in Algebra 1, probably discussed again in Algebra 2. So what's really happening here? Well, it says that the rate of change of the weight is directly proportional to whatever the current weight is. So dw dt equals kw in this case. Notice, if I'm going to take an integral of this to try to solve for w, and I want to get rid of this dw dt there, I'm going to have to get the w over to the other side. So I'm going to have to separate variables to do that. I'm going to multiply both sides by dt. This is really supposed to happen in part B, but anyway, I'll multiply both sides by dt. That's going to cancel that. I've got a w here. I need to divide by w. Remember, that's a 1 dw. And so what I'm going to end up with here is I'm going to have the equation 1 over w dw is equal to k dt. I've got 2 equal things. Their integrals should be equal. That's going to be a natural log of the absolute value of w. That's going to be kt. We're looking at a t variable there. Don't forget your constant. Really important, okay? And so this is a log base e. So I could write this as e to the kt plus c equals the absolute value of w. Or I could raise e to the natural log power, raise e to that power on the other side. Remember that e to a natural log power, those two things offset each other, just leaves me with the absolute value of w. And then that's equal to e to the kt plus c. As you've already seen in several cases, I can remove that absolute value. That means that this could be positive or negative, depending on how things work out down the road. And remember, we've also used that little trick where we can rewrite that e to the kt plus c as e to the kt times e to the c. And I'm going to let e to the c be represented by the constant c naught. Okay, so I'm going to get a little easier, simpler equation here. I'm going to rewrite it. W is equal to c naught e to the kt. Okay, now if you recognize that from the original statement, anytime you've got this directly proportional relationship, if you've got a rate of change that's directly proportional to the original function, directly proportional really to the y value, but we call it w in this case, you're always going to end up with this equation that is really essentially just the PERT formula. Okay, so if you're doing a multiple choice question on the AP exam, you can really just jump straight to this equation. That's your initial value, and you can solve for whatever you're missing in the particular problem. In this case, they wanted me to solve this and go through the whole process, so I did. That's the general solution. Okay, I'm going to continue with this problem. I actually made a couple of changes in what part C stated, so if you saw that on the screen previously, you can ignore that part. But what I now have is find the particular equation for the weight if the bird has an initial weight of 4 ounces and then weighs 8 ounces after 2 weeks. So they're usually going to give you an initial value. It's possible that it might not be a t equals 0, and you might actually have to solve 2 different separate equations. This one's kind of nice, though. It works out very well because they give you an initial weight of 4 ounces, and you're really trying to find C naught, but they're telling you that t is 0, and e to the 0 power is just 1, and that tells you that 4 is really just C naught times 1, which means C naught's really just 4. So if they give you an initial value, you can just go ahead and fill that value in. So now I know that value. What I don't know is the K value here. It didn't tell me what percent change the bird's growth is occurring at, that sort of thing. But it does tell me that it weighs 8 ounces after 2 weeks. So I have an additional piece of information. Now that I've knocked out one variable, I should be able to go back and find K by filling in these 2 values here. So they've told me that I have 8 ounces after 2 weeks. So that's K times 2, or 2K up here. And I can solve this. You're going to have to use logarithms because you've got e taken to a power here. Get rid of your coefficient first. Divide both sides by 4. And what I'm going to have here is 2 is equal to e to the 2k. Now I can convert this over into log form. I should be able to use a calculator to close this thing out. I'm going to write this in log form. This is going to be a log base e. Remember, log base e is the same thing as natural log. It's a log base e of my result equals my exponent. Remember, logs are exponents. So I can take the natural log of 2. That's equal to 2k. So that's about 0.693147 is equal to 2k. I can divide both sides by 2 here, and I'm going to get k is approximately 0.34657. Try to go several decimal places past 3, or you may get some error. And that's my K value. So that's controlling the rate that's making this grow in a way that matches this data right here. So I can substitute K in. And anyway, should be able to use that equation now. That's what's referred to as the particular solution. And so the last part of the equation here, or the last part of the problem asks me how much will the bird weigh after 6 weeks. Should just be able to substitute 6 in there and find an answer. So that's going to be 4 times e to the, multiply that by 6. That's about 2.07944 power. Again, if you leave it in your calculator, you'll get a little more accurate answer. And let's see, if I do that, I end up with approximately, oh, it's almost exactly 32 ounces as my final answer. So again, the big thing with these problems, if you happen to know already that you have a situation where the function is changing in a way that's directly proportional to the original function, you really can jump directly to that C naught e to the kt function. You don't have to go through the whole thing that I went through in the setup. However, this particular problem asked me to write the differential equation, then to solve the differential equation, then to go back and find the particular solution. So you just have to read the question. But if it just asks you for this part, you could really just jump straight to that equation, which is essentially the PERT formula.